It's now recorded. So we want to talk about today. We want to talk about ORMs, which are object relational mappers, and we want to understand what they're good for. We want to play around with Sqlite, which is the most popular Node.js ORM. Also, we want to integrate such an ORM in our little services. So we're going to have services with persistence, and we're going to build a couple of services. I don't think we're going to have time to go through everything, but if we don't, we'll just continue with a couple of examples next time. So first things first, why would I need an ORM? What is an ORM and why would I need it? So when I write complex applications, I might want to have an abstraction layer which is going to let's say cover the part with which represents actual persistence. I'm going to store my data in a relational database in this case. But I am going to store my data in a database either way, whether it's relational or non-relational, because in most cases I want persistent data. Now, the way I could do this by actually writing SQL queries by hand. But the way this is done in modern applications is via this abstraction layer. This is something which allows me to talk to write in terms of the objects of my application and have persistence, but in a way which is transparent to me. Now, ideally, I wouldn't care what database I use, and there are some initiatives such as something like FaunaDB which actually try to do this. So try to abstract persistence entirely so you can have any kind of database as your backend. However, Sqlite doesn't do that. There's quite a big difference between the relational model, the database is based on relational models, and databases based on something else. Those are actually pretty varied. So I can't actually, it's difficult to abstract at the same time something like MySQL and something like MongoDB. However, staying within this relational database realm, what I'm going to be able to do is I'm going to write my application while being indifferent to what particular relational database server I'm using. Right, so I'm going to, for example, after I've written one of these applications, I could change two configuration lines, well, two or three configuration lines, a configuration object, and replace it, right? So we're going to write on a particular one, and then we can replace it with another one with minimal effort. So that's what I mean by abstracting it. But why would I need that? What are the advantages that I derive from abstracting the storage part? So the first one is that my main the main thing that matters to me is to handle complexity. In the larger software projects get, the more important their complexity becomes. So I need a way to manage complexity and to make understanding the application simpler. But apart from that, um, there's something which is called the object relational mismatch, and this means that object-oriented languages, whatever kind they are, actually look at data from a different perspective, uh, when compared to relational databases. There's a trivial point to this and a deeper point to this. The trivial point is, for example, the fact that my types are not the same, right? So what's a varchar, right? When talking about in an OOP language. The second one, which is more subtle, is the fact that the way that relationships between data items are represented in an object-oriented language is different from the relational model. Because if I say, for example, that a building has apartments, in an OOP language, that's going to mean that the building is going to have an attribute, which is going to be a collection of some sort, of some other objects which are of type apartment. Now, if I look at how this is represented in a relational model, the relationship is going to be reversed, which means the building is not going to know anything about the apartments, but the apartments are going to have a foreign key to the building, right? So it's the direction is reversed. The third thing, which might interest me in this, is that web applications are going to be in contact with user input, right? So the user is going to input something in my application, And if I'm not careful, this is going to lead to open the door for a series of attacks, which are generically speaking, generically named SQL injection. But I might think about them in an even more general term, which is code injection. Right, so I should consider any user input as being hostile. That's because whilst I can accept or I can either handle a risk or accept that the risk might occur, I'm not going to be able to choose when something I've decided to do which is risky is going to become an actual problem, right? When the risk is going to manifest itself. That's not within my power. So all user content, all user input should be considered hostile. Now, when it comes to SQL injection, the way to look at it is that I have an input field where I imagine that the user is going to give me the name of a puppy, and they're actually going to give me an SQL command. And depending on how it's written and how it's represented, it's going to be run as an SQL command on my server. Now, this is a problem, and it can be handled in a variety of ways, which maybe are not the object of this course. But what's important is if I try to handle it myself, first of all, I'm going to have to handle it everywhere, and this is a bad idea if I do it instance by instance. So probably what I'm going to do is I'm going to write something abstract which is going to handle it. So I'm going to have an abstraction layer built by myself. However, this abstraction layer has to be maintained and so forth. So I can pass this responsibility to my persistence layer, to Sqlite. Now, the actual database backend which we're going to use is going to be somewhat relational. It has the relational model, but it's somewhat different from what you've seen until now, because we're going to be using something a lot simpler, which is SQLite. Now, this functions as a relational database, but it doesn't do what relational databases typically do. Which means if I look at MySQL or at the SQL Server or at Oracle, the way they function is that I have a database server, which is a networked application, right? It's an application which communicates in the network, and the client, which communicates with the server via a network protocol. Now, for SQLite, things are a bit simpler in the sense that it just uses a file. It just opens a local file and it treats it as a relational database. However, as I've mentioned earlier, we could at any point, without modifying the code in our application, except for a couple of lines which are the configuration part, we could switch databases. With that being said, let's just start looking at building and looking at some examples, so we just have the chance to comment what's happening there and better understand how this all works. So the first thing we might do, we want to just have something which persists, connects to a database, and then persists something in the database. So the first thing we're going to do is have a file which is going to be check connection, and we're going to have a package. Now let's just make a folder which is called general, so we can isolate this. I'm going to move this one sec. And we're also going to need a package JSON because we're going to have two external dependencies. Right, so our dependencies, first of all, we're going to have Sqlize, obviously, because that's the point of the exercise. Now, if I would implement such an abstract data access layer, right, an ORM, it would represent the generic concept of persisting object data over a relational database. What it's missing is the part which is database specific, right? Because if you think about it, at the end, the framework, the library, is going to have to generate some SQL commands and run them on the database. Now, this is going to be database specific because this is another point about relational databases, which is whilst theoretically SQL is standard, it's not all that standard. So there's an SQL standard, of course. And if I run an insert on MS SQL or on MySQL, I'm going to run the same insert, most likely. However, if I look at the details of things, right? If I look, for example, at how can I extract the year from a date, I'm going to have radically different implementations. This is not going to happen if I use an abstraction layer. Something else to note before going forward is that this idea of an ORM is not something JavaScript specific. You have ORMs everywhere. So you have an actual, let's say, standard interface for ORMs in Java, which is called JPA. You have SQL Alchemy in Python. You have something more Microsoft flavored, which is Entity Framework in C Sharp. But you also have nhibernate, which is something Java-like in conceptual terms. So this is not actually something JavaScript specific. It's an enterprise pattern, right? It's a way of solving a common problem. This can also be applied to RESTful services themselves. So RESTful services are also basically an enterprise pattern, right? So, which is why they look similar in whatever language. Right. So let's just connect. So the first thing we want to do is, like I said, we want to have the dependency for Sqlite, and we also want to have a driver, so something specific to our database. And in our case, it's going to be SQLite 3. It's going to get installed. We don't really care to look at it. So the first thing we're going to require Sqlite. Now this represents the library. The second thing, we want to have a connection to the database, and this connection is going to look a bit different for SQLite 3. I'm going to note every difference that's in SQLite versus something like MySQL. So if I connect to something like MySQL, I'm going to have to provide a user a password and the database I'm connecting to. Now, for SQLite, this is a bit simplified. So what I'm going to have to specify, so let's just look at how to create a connection. Notice that Sqlite here is with a capital S. This is meant to signal the fact that it's actually a constructor. And based on this constructor, I can create a connection. Now this connection has to have something, which is the dialect, right? The dialect is SQLite. And these are the lines that if I'd switch databases, I'd modify. This is the configuration part. And since it's a file for SQLite, I'm just going to say it's stored in sample.db. SQLite is going to create this file for me if and when I need it. And the next thing, we just want to connect to the database and then just signal that we've connected. So I'm going to have Sqlite authenticate. Now all these Sqlite operations are return promises. They're asynchronous. So here I'm just going to want to write something to the console after we've connected or the error. Right, so Sqlite authenticate, and then if we've connected, we're just going to write we are connected. So let's just run this and then see what happens. What? Oh, I've edited the wrong thing. All right, it's this. And this one we want to delete. Right. So let's just run it again. So it said we are connected. Right. So after this point, we can do stuff with our connection. Now, obviously, what we've written here is not really all that useful. What we want to do is have some way of defining persistent objects, right? So objects which are saved to the database. So let's go to a new example. We're going to call it create tables v1 because we're going to have multiple of these. Now, when defining, if I think about persisting an object, I'm going to have to specify a bunch of things, right? Intuitively, I'm going to say all of the kittens are stored in a kittens table, for example. Uh, so I'm going to have to define how it is persisted. Now, if I look at something like Java or Python, I have some class definitions, and the way that I'm going to define how something is persisted is going to be by using add notations on the class definitions. Now, this all these words mean nothing here in JavaScript. So what I'm going to do is I'm going to have some objects, distinct objects, which are going to define this. We're going to define how something is persisted. And let's look at such an object. So first of all, we're going to to have this, right? The connection part. And then the way to define something like this is, for example, const author is Sqlite define the name of the entity and then the definition of the entity. And here I'm going to define my attributes. So let's say our author has a name and it has a type. Although what I've written here is actually a sort of shorthand, right? It's what I'm supposed to write is the name of the attribute and then an object defining how the attribute works. In this case, however, we've used a simplified form in which we're just applying the type. Now, where did I get the type from? Well, if I look at the documentation for Sqlite, right, which is you can find on the internet, we're actually using version 6, but this is going to be the similar. And if I look at data types, sorry, I'm going to see what data types correspond to what. And for most kinds of data types, they're going to be common for all databases. But there are some cases where not going to be able to use them unless I use a particular database backend. Now, some of these I don't really need, but for example, if I want to do geospatial data processing, I'm going to need some geometry. And geometry isn't something that I have in something like SQLite. SQLite is something really fast and really lightweight, but it doesn't do this sort of stuff like near queries and area queries and so forth. Right, so but generically, if I talk about SQLite string, this is going to be a varchar, and if I look here, I can actually specify its length. Right, so it's by default is 255, but I have this handled, the fact that my types in my object-oriented language don't correspond to the types in the relational database. Now, this only exists in my application, so the next step is going to be to have tables, basically representing a table representing this author. There's a couple of problems here, right? The problem is I've not specified the table name anywhere. Now, the reason for this is that we're in an approach which is called convention over configuration, which means this was initially introduced by something called Ruby on Rails, and it represents the idea that when I'm writing complex stuff, the library is going to have a convention in mind. And if I want to adhere to that convention, the library isn't going to ask me much. It's not going to ask me anything else. It's going to use the convention. So all I need to do is to specify the things which do not adhere to the convention, right? So in this case, what I'm saying is that my author has a name and an email, and observe that I've not set the table name, for example. Now my table name is going to be authors because the entity is named author, and it's the plural form in English. The second thing which is going to be generated for me and which I need is an ID. Now the ID is going to be added automatically. Now why do I need an ID? Now consider two authors in memory. Now if the authors have the same name and the same email and they're in memory, I'm going to be able to differentiate between them by their addresses. Whilst if I store them and I have tuples with the name and an email, they're going to be identical. So in order for them to not be identical, I need some sort of unique identifier. And it's going to be called ID, and it's going to be an integer in this case. Now, this exists for now just in the memory, just in my application, so I need the tables generated, and I can do this with Sqlite sync. Now, something to note is that sync in this form actually represents a create table if not exists, right? So if the table does exist, it's not going to be changed. I have a way to go around this, which is passing a parameter to sync. We're going to see it in the next example, which is called force. And then it's going to drop the table and then create a new table. So if we run this, I'm actually going to see in the command line what the creation command was. Now, what if I want to look at the database itself? Now, for MySQL, I would connect with the command line client. I can do something similar here, which is I can use SQLite 3 and just the name of the file, which is called sample.db. Now, there is something a bit stranger about SQLite, which is the fact that the create, read, update, delete, etc. commands are the same as in SQL, but the meta commands, the one which allow me to explore the structure of my databases, are not the same. So in this case, and I'm going to give you the equivalent. So in this case, if I want to see the databases I have at my disposal, I can write .databases. In this case, they're files. Now, if I was in MySQL or Oracle or whatever, I could have said show databases. If I want to see the tables, I can do .tables, and I can see that a new table was created indeed. In a more, let's say, traditional relational database, I would have written show tables. If I want to see what a table is, I can do .schema authors. And in this case, it's just going to give me the create command. Where in MySQL, I would have said describe authors, and I would have got a new neat little table, right, with all the fields. Right, so there are some differences, but mostly it's the same. It's the same thing. Now we're going to exit this and go to our next example. Now we've created an author, and this is fine, but it's not really the real case, right? In the real case, I'm going to have a bunch more things. So the things I'm going to have is multiple entities, relationships between entities, validation, default values, and so forth. Now, something to note, if I look at what was actually created for authors, I have my ID, right, which is an integer, it's a primary key, it's generated by the default strategy of the database, which is auto increment. I have the name and an email, which I've explicitly said I need. And then I have two timestamps, right, the created at and the updated at. And these are they're generated automatically by Sqlite, but I can, if I want, convince it to not do that. So let's create something a bit more complex. We're gonna have create tables v2, sorry, v2.js, and in this case, we're gonna have the same connection. Only we're going to pass a parameter, so define timestamps false, and this is going to make the ORM not generate timestamps. They're used in various mechanisms, but we don't care about that at this point. Then we're going to have our author, but we're going to have it, look at it here, so it's a name type. But I said we can actually write name definition. So we're going to have the same thing, but written in a bit more complex way. So it's going to look like this. Now let's look at this. So it's name definition. The definition must contain the type. So the type is mandatory. However, it contains a bunch of other stuff. So allow null false. Now this is something I would have written in a create statement in SQL, right? It's an attribute or a column which is non-nullable. Then I have the email, and again I have allow null false, and I have a validate key. Now what does this do? Well, this actually checks if the value corresponds to some constraint. Now, interestingly enough, the constraint needn't exist in the database engine itself, because Sqlite is going to handle this for us. And if I look at let's look at the available constraints. If I look in the documentation at the validation part, I can see that I have some pre-packaged constraints. I have, let's call them the naive constraints, such as is email, is URL, is IP, etc. Now, why am I calling these the naive constraints? Well, if I think about validating something as an email, this is not actually going to validate a real world email, because the structure is relatively complex. It's going to validate something adjacent to that. It's going to check if I have some characters, then an sign, and then some other characters. But real world emails actually have a more complex structure than that. Now, if I do want to do full validation, what I'm going to do is I can use a validator which has a regular expression, such as this one. Now, if regular expressions don't fit my needs, I can actually do custom validators, which are these kind of functions, which have the chance to throw an error. So either they throw an error or they don't. This is even thing, is actually something which we could have done with regex. This one isn't, right? So it refers to another field, so it's not something which I could have validated with regex. There are also things which I can't validate with regex, in the sense that there are some structures which cannot be represented in regular expressions. This is a discussion about language grammars and so forth. Suffice it to say, I can say something like a bunch of A's followed by a bunch of B's. I can actually represent this. But I can't say a bunch of A's followed by the same number of B's, right? If it's valid or not. But if I need something like this, like I said, we can have custom validators. Now our authors are actually accompanied by another entity which is called message. Again, allow null, false, etc. And then I have some content which is text, which is a data type which is text larger than a varchar can contain, basically. Now, something to note about validations is that if I validate a particular column, null, and the column is nullable, null is valid against any validator, right? So null is an email and an IP and the number and the string of whatever length, right? So if I want to not have null values, right, to not be able to insert something undefined, I have to have allow null false and my validations, whichever they may be. Now this is mildly more useful than just the author. However, what we actually want is for the author to have many messages. Now these objects we're defining, author, message, they're they're relatively complex and they handle interaction with the corresponding entity in the database. They have a bunch of methods, and some of these methods refer to relations. So I can do has one, I can do has many, and I can also reverse the relation in the sense that I can say message belongs to author. We're also going to see, but probably not today, how we can do many-to-many relationships. Like I said, we're probably not going to get to this example today. Now, our next problem, like we said, is that if we sync it now, if we use the Sqlite sync logic, the author is not going to be recreated, right? Because its create table if exists, which means none of this stuff is going to matter. However, we can force it by doing force true. Right, so let's see what happens if we run our we run our create tables v2. So the tables were dropped, right, if they existed. The author looks somewhat the same. That's because the constraints we've added are actually going to be enforced by Sqlite, not by the database itself. And then messages, I notice that it actually has a foreign key to authors. And I've also, by default, I've also received some cascade instructions. So what happens if I delete a parent? If I delete a parent, what happens to the children? Now, I might not like the default, so I can configure this, but I do have a default, right? And the default is when I delete an author, the children get their author ID set to null. And if I update the ID of the author, it's updated in the children as well. Like I said, if it doesn't fit my needs, I can actually change this. Now let's look at something else, which is also tied to creation. What might happen is that I might have models in my database for which I need virtual fields. Now, what are virtual fields? Now, it might happen that I have, for example, I'm storing the first name and the last name. And in some sort of application of some sort, I need a full name, so something which contains both the first name and the last name. Now, if I'm in this situation, the simplest thing I might do is to keep the full name in the database. But I have to notice that I'm actually keeping redundant data. So what I actually want to do is to not keep the full name in the database, but to give the impression that I'm doing it. Now let's look at a more complex example and comment it and see it there. So it's create tables v3. So in this case, I'm going to have two things. One is virtual fields and one is controlled access to fields. So let's assume that we have an order and a client. Now, if I look at the order, I can see a couple of interesting things. So the order can be fulfilled and it's emitted at a particular date. Now for fulfilled, whenever I add an order, if I don't specify if it's been fulfilled or not, I actually have a default value here, right? So if I don't specify anything else, what's going to happen is that the value is going to be false. Emitted is even more interesting in the sense that its default value is actually Sqlite now, and this represents the current time in server time. Now, why am I saying this as in server time? Because web applications actually have an additional restriction when it comes to dates and time and so forth, which is my users are not in the same geographical location. So they have some client time, and the server is in one geographical location, so it has some server time. And I have to handle this if I have distributed users. Uh, this is not the time to talk about this. However, so this is the way where this is how I could invent my own timestamp basically. As for client, well, for client, it does have an allow null false and some validators. That's not really all that interesting, but it also has a setter. So what the setter is going to do is you can provide me the value in any form, and I'm going to have a way to make it the same as the other values, to homogenize it. In this case, I'm going to store everything lowercase. The same for last name. All right, so these are accessors. And I also have something else, which is this. I have in my model definition, I have an additional object, the third object here, right? So I have the model name, then the attributes, and then I have additional things, right? Additional parameters. And in this case, I have some getter and setter methods. Now, what these refer to is a virtual property. So full name is not going to exist in the database. What's going to exist is just first name and last name. However, when you access this object, right, if you find a bunch of clients, you are going to have a key which is going to say full name. It's just going to be constructed dynamically. And this is how to get virtual fields. Now, this particular implementation is not necessarily correct in the sense that the strategy of just splitting the if I want to set a full name, what I have to set is both the first name and the last name, and this particular strategy is not correct. Uh, I should have a better strategy to setting the first and last name. So this just splits things based on space, and it considers that the last name is the last word, and the other ones are the first name. Now, the last problem we want to look over when talking about entity creation is the fact that if I look at the file such as this is a really simple case, right? It has two entities, but in a real application, I'm going to have tens or hundreds of entities. So at least in this representation, I have them all in the same file. This is not going to scale, right? I can't have all my entities in the same file because it's going to be impossible to understand which is which. One way of handling this is to group them in different files, either based on some sort of group of entities they belong to, or just each of them in a separate file. Now, the problem I'm going to have there, however, is that if I need to define relations, such as here, right, the entities have to be aware of one another, and I've declared them with Sqlite define. And Sqlite define define is a method on Sqlite, and Sqlite actually represents a connection. So if I make a new instance of Sqlite, and if I define the author on an instance of Sqlite and the message on another one, I'm going to get two entities which are not aware of one another, which means I'm not going to be able to do author has many message. So what I need to do is to have a way to put entities in different files, but to have them use the same connection. So let's see that. So let's consider a book. We have a book, and we have our create tables v4. So the question becomes, how do I define the book and how do I import it here? So let's just go to v4 and put in the boilerplate. So we're obviously going to have a connection, and we're going to have the Sqlite sync part. Now, if we go to book, we want to export something from here. So it's module export something something. But I can't actually export the book. What I'm going to do is I'm going to export a function which produces a book. So it's going to be a function of a connection and a library, which is going to do return Sqlite define, and this is going to be my book definition. Let me just get it from something. I think it has a title and a content. No, a title and a description. Right. Now, how am I going to use this, however? It's well, I can just require this, but I have to take into account that require actually gives me a function. It doesn't give me the entity. But I can say const book is require dot slash book. And then I can call this function on Sqlize and Sqlize. And if I run this, requires not a function. Okay, const book. Let's go back to book for a bit and see. Oh, it's module exports. Right. I can see that the books table is created. So this is how I can compartmentalize my entities. Now we're going to go back to this general discussion in a bit to look at how complex queries can be constructed. However, what we want to do next is just build a simple REST service which has persistence. It's going to have persistence over SQLite, and it's going to do the basic operations, so the CRUD operations: create, read, update, delete. So let's move to a new folder and have simple API. And this is going to be a server, so let's have a server.js and a package.json. Now we're gonna have a series of dependencies, so let's just install them. And these are going to be Express because it's a server, Sqlite because it's persistent, and SQLite 3 because this is the backend we're using. So this is the storage engine we're using. Right, so everything's been installed. We have a bunch of vulnerabilities. This is because we're incidentally using an alpha version of Sqlite. But getting back to our server, we're going to need our server part. So Express is require Express. Our app, which listens to a port. Right, we're also going to need our Sqlite part, right? So let's just go to check connection here and get the connection part. And we're going to need something else, which is if we only do gets and deletes, we're not going to need anything else. But if we want to either create or update something, we're going to need body parser, right? So that we can access the data that our user sent us. So let's say require body parser. And this has to be applied as a middleware, so let's use app use body parser.json. Now, if we're persisting an entity, we need an entity. We're going to keep it really simple, so we can let's say isolate this part. One sec, let me just get our entity. It's going to be a book, and our book is going to have a title and content. And maybe we want to do to give up the timestamp. So define timestamps false. Right. So what now? Let's see what endpoints we need. Right. So what combinations of request method and address we need. So let's we're probably going to have a list of all the books. This is going to be app-get books. Now, like we said, most of our Sqlite operations are going to be async, so we're going to write this as an async function of request response. Then we're going to need to add a book, and this is going to be post to books. We're going to want to get a particular book, so this is going to be get books / an ID. Let's call it bed. And this sort of address is going to be useful to do update a book with put and delete a book with delete. Additionally, we're going to do something which is a bad idea. So we need to create our tables somewhere. And typically in a real application, we'd have a different file where we do Sqlite sync, right, which has the same entities, imports the same entities, and so forth, and does Sqlite sync. We're going to put it on an endpoint. Obviously, we couldn't do this on the internet, but for celerity's sake, let's just do it now. So this is going to be a sync of request response. And this is going to destroy our data if we want to. Now let's look at the general structure of. So the first thing we have to do is create our table. So let's look at the general structure of such a function which handles a request. So a lot of things might happen, right? Let's think about it. So I might not be able to connect to the database. I might feed it some SQL with errors. I might something which I'm trying to access might not exist. I might not have permission to do something, and so forth. Right. So I have to handle this part where an exception might be thrown. So here we're just going to write our error to the console. Uh, since we're going to do it like this, we're going to have a lot of repetitive code. There's a better way to do this, and if we have time, we're going to do it. It's related. It's the way the last exercise in your last tutorial went, which is I hope you had time to look over it, which is I can use error handling middleware. Either way, on any code path in this function, I have to respond to the user. So in this case, I'm gonna say status 500 because this is probably something the user can do nothing about. Message, some error occurred. I don't want to be too specific because this is the typical way an attacker would investigate how my application works. They try to create error conditions and see the stack trace or something like that. Now here I'm going to just await Sqlite sync, force true, and then assuming this doesn't throw an exception, we're going to say status 201, and we're going to say message tables created. We can already test this, but let's wait a bit and implement something which we can see works. Which is we're going to want to implement initially at least get and post, right? Because we can add a book and then see that it's been added. So the general structure of any of these is going to be similar. So let's just copy paste this. Now when I request books, ignoring anything else, ignoring stuff like filtering or paging or sorting, which we're not going to do in this particular function. Uh, the way I can get my books is by saying books is await book.findAll. This is a finder function, and it's going to work similar to a select. Now, some questions might appear here, which are I have a bunch of clauses I can use on a select, which represent some fundamental operations on the relational model, which is selection, projection, and joining. And we can do all of these, just not in this particular function. We're going to do them in a separate example. We're going to go back to queries after writing this simple service. Right, so here we're going to just send the books. Now, if nothing explodes, so to speak, any response is valid, right? So an empty array of books is a valid response to get books. Now, what about post? So for post, what we want to do is, again, we're going to get this, use this try catch structure. So for post, we have a book which was sent to us in the request body. So we're gonna say const book is request.body. So here it was 200 actually. Wait. Right. So in request.body. Now we can use something which is called create. There's two kinds. I can create in two ways, right? And create actually is a helper method. Let's see what that means. So we're just gonna say await book dot create of book. Now, apart from doing book.create, I can use something which is called bulk create. So if you think about it, what I can pass to book.create is a book-like object. If I do bulk create, I'm going to pass it an array of book-like objects, and it's going to create all of them. Now, why am I saying this is a helper method? So create doesn't do anything specific on its own. It just calls to other methods, which are build and save. Now, what build does is it builds an object, a valid book object in memory. And if something doesn't pass a validation or anything, the process is going to stop here, and I'm going to get an error. Whilst what save does is it constructs an SQL query and it runs it against the database. But create is a nice way of encapsulating both of them. Now, after I've created the book, I'm just going to say message created or something. Right? I'm just going to signal that it's been done. Right, so we're ready to test this in a first form. So let's say node mon. Let's just node mon it so it's we don't have to restart it. Server.js. Okay, so we've put this in the wrong position. It's supposed to be after Sqlite was defined. Everything's fine. Now let's go to our postman. And the first thing we're going to do is we're going to sync our table. So we're going to say a request to HTTP localhost on port 8080/sync. So it says tables created. And if I look in the console, because this shows debug information, I can see what it's actually done. Right. The second thing, let's just get our books. And what we're expecting to get is an empty array. And indeed, we get an empty array. Now let's add a book. This is going to be a post to books. And I have to do a couple of things. Since I'm adding something, I have to specify what kind of entity I'm sending, and I'm going to do it with content type. So what I'm sending is going to be JSON, so application JSON. And I have to actually send the book. So let's go to raw here and write a little book. So it's just the title and the content. So it says created, and if we get the books again, we're going to see we now have a little book. The ID was generated as the create table statement actually states, right? It says auto increment. Right, so let's get back to our source. We have three more methods. The first one is we have to get a particular book. Now, if we want to get a particular book, there's an additional thing we must do. When searching for a particular book, the book might exist or it might not. And if it doesn't, we have to send the user error. It's something the user can correct. So let's just take this and put it here. Nope. So we're going to use another finder. So instead of find all, now find all is not the only method on book I can use. So find all is accompanied by find one, which is going to give me the first record satisfying some condition, and and a specialized find which is called find by PK. So it's a in our case it's going to find something based on the ID. So we're going to say find by PK, and the PK is going to be request params bid. Now we don't actually have to worry about conversion and everything because Sqlite is going to handle it. This is going to possibly return a book, not a bunch of books, so it's a singular book. And we're now going to wonder if the book exists. So if the book exists, we're going to send it to the client. If it doesn't, we're going to give them a client error. Right, and this represents a nice prototype for what we want to do with put and delete, right? Because neither put nor delete makes sense unless the book exists. So let's do that. Let's just go to put, and we're going to copy paste this part. Right, so if the book exists, we want to do something and then say it's been done. Typically, we're gonna say accepted. So we can say await. We can do it manually, so we can just change the book manually and then say book.save, or we can just update book on based on request.body. But let's note something else. If I do exactly what I've done here, right? If I leave it like this, what's gonna happen is the user is going to be able to change my ID, for example. Maybe I don't want that. What if I don't, right? What if I want the user to only change particular fields? Well, I can use a second parameter, which is an object with a bunch of keys, and say fields and supply a list of fields. So I just want title and content, and we're done. We're going to test it shortly, but first let's go to delete. And for delete, the logic is similar. The difference is going to be that instead of updating, we're going to have a method called destroy. So it's time to test this out. Um, for now, obviously our server restarted a bunch of times because it's been run with nodemon, but our data is now persistent. No, it didn't. It did. Right. So our data is now persistent, so it persists between server restarts. Now, first things first, we only have one book, so let's get it. So it's gonna say get book /1. Now, given this address, we can modify our book. So let's try to modify it, and let's also try to change the ID, which shouldn't happen. So put to localhost book /1. Since it's a put, we're sending a new variant of that book, so we have to specify the type. And in the body, we're going to send our little box. So let's just cheat a bit. Let's just take it from here and say modified title and modified content. And I said we're also going to try to modify the ID, which shouldn't happen, right? We send this, we get an accepted back. And if we now get books1, obviously since we got this, the ID was not modified because it wouldn't have been 1 anymore. And these are modified. So modified title, modified content. Now what about delete? I'm gonna go here, delete it. And after we've deleted it, if we try to get it again, we're going to get a not found. Right, so this is a simple service implementing CRUD operations. Um, Now there's still a bunch of stuff missing here. So the first thing I must wonder is how would I represent multiple entities which are related in some fashion? And we're going to go back to that. But first, let's investigate queries a bit, right? Because like I said, if I look at something like book.findAll, this is a select star without anything, without the where, without a join, without anything else. So the question becomes, how would I do those, right? I'm interested in doing something more complex. This isn't useful enough. So let's go back to general, and we're gonna say we have queries.js. So first for the boilerplate, one sec. We have Sqlize, we have a connection, and we're gonna have a person, right? Where a person is going to have a name, an age, and a salary. Right. So in order to do some queries, you're going to need a bunch of them. Let's just organize them. Everything is going to be a sync, and this is not going to be all that that well organized. So we're going to have a main method which is a sync. So we can just do a wait inside it, and then we're going to have main. And here let's do a try catch. There's nothing we can do except logging the error to the console. So like I said, first we have to create some persons, and I said I can use something which is called bulk create, which receives an array. Right, so just going to await this person bulk create. Let's just organize this for a bit. Right. So we have a bunch of people here. Now let's assume that instead, if I do find all, I'm going to get something similar to what I got for books. Let's just do find all first. So let's say let people is await. Oh, we've eaten a paren here, right? Await person dot find all. Oh, we've missed something else, which is we've declared the person, but we should have done await Sqlite sync of first row. Right. So let's see what the people are. Right. So this looks a bit strange, right? It's not quite that I expected. I would have expected to get something which just represents the values from the database, but I didn't get that. What I got are some relatively complex objects. And this actually makes sense because I can, instead of giving me just the values, what the Sqlite is giving me is some, let's call them helper objects. And these helper objects have a bunch of helpful messages. But the question still remains, how can I extract this? How can I get it? Now, as a trick, if I try to serialize this object to JSON, I'm going to get these data values. But I can get them directly by saying find all raw true. And if I run this again, I can see I just get John, Jim, and Jane. Right, so this is a problem which we've solved, but we didn't know we have. Let's go back to having selection and projection and stuff. So let's consider we want to select everybody who is named John. Let's do this. We're still going to do it raw, but we're going to say where and then some condition. And the condition, now equality is implied. The way I can look at this is that what I'm doing is getting each of the records in my database and applying a mask to them. And if the mask fits, then the object is retained. Otherwise it's not returned to the user, it's ignored. So I'm going to say name John. So this is where name equals John. And I should print the result. Sorry, let's just move the result. All right, so we can just see what's happening. Oh, John with a lowercase g. Right, so I now only get John. Right, so this solves part of my problem. I have some sort of selection. How do I get projection? I'm obviously not going to be able to see a join here. I'm going to see it in our next example because I don't have more than one. What am I joining to what? But I can do something else. So apart from where, let's just make this a little prettier. So let's go here. Right, so to just see which is which. So where, and I can also say something which is called attributes. And this is going to be an array with a list of attributes. So let's say we just want name and salary. So if I run this, I'm actually going to get just name and salary. Right, but this is fine. But what about more complex conditions? Right, because this is not quite, so it's I don't have any operator because I've ignored equal and it just says name John. What else? Well, the structure of such a query, right, with the where, isn't this is a simplified variant, just like we've seen for define. So it's actually name and then a sort of definition of the what should happen to name. Let's add another line here, which is going to be useful shortly. So traditionally, so in the some time ago, operators in Sqlite were strings. Right, so I would have just, if I wanted to say greater than something, I would have just written something which looked like this. Now, this is not true in the current version. In the current version, operators are symbols. Now, from usage perspective, it's not much, it's not really all that different. What I can think about, what I can consider symbols to be, well, symbols, I can say that they behave just like strings, with the exception that they have guaranteed uniqueness. So there's just one of that symbol. So they're really useful to represent concepts at the library level, for example. So one such concept would be the concept of greater than, right? So or one such concept would be the concept of something being iterable. So let's see how we select everybody which has who has a salary greater than 1,000. So strictly greater than. Now, as an aside, if I look at the documentation, which I encourage you to do, I do have a complete list of operators here, and they're explained and everything. So let's go here and say people whatever is with John something. People is await find all. But instead of selecting people named John, we want to select all the people which have a salary greater than some value. So we're going to say where salary, because it refers to salary. And then instead of having a value, we're going to have a, we're going to have a definition object. And in this case, we're going to use a GT operator. So it's going to be op.gt 1000. And now you can see what I meant by saying that it's basically applying a mask to each of the records. Because so if I go to a record and it fits this, it's kept. Otherwise, it's discarded, right? It's not in the result. Interestingly enough, I can actually also do ands really easily here. So let's say it's greater than 1000 and less than 3000. Because salary has to fit all of these. Let's see what we get. We should only get the middle one. So it's Jim, who has a salary of 2000. Right, is there anything else? Yeah. Now let's consider all these can be composed in a more complex structure. So let's consider, let's say people is await person find all. Let's just copy this. So it's person find all, and let's say we want to have people which have the salary condition or something else. Let's say they have an age between 20 and 25. How would I do that? Well, instead of having salary directly in where, what I'm going to do is in where I'm going to have an op or, and or is actually going to have an array of possible things that might be true. So the first thing that might be true is this condition, right? So if salary is within this interval. The second condition that might be true is, let's say, age something, right? So age of between, and this actually has a, let me see, just this has an interval, so it's between 20 and 25. So either they have that salary or they're between 20 and 25. So this is actually going to select two of them, I think. It's let's just see. Right, so John and Jim, right? Because John doesn't have a salary in that interval but is 24, and Jim has a salary in that interval, even though the age doesn't fit. So this would be a short look at queries. Now let's go back to our service initiatives. So let's make a new folder and let's say we want to represent a one-to-many relation. We can actually cheat for a bit in the sense that we can start from our existing server. Why? Because if our parent entity is book, uh, operations on the parent entity are independent on from what I do on the child, right? So I can just start from something handling books and add chapters to books. So first things first, I think we've copied it, right? So this is our, no, I have to copy the files, one sec. Right, so we can start from this. One sec, I'm going to pause for a bit. So we got our initial state. Now let's add our chapters, right? In order to have this more easily testable, we're going to keep our chapters similar in structure to the book. So I have chapter, which is Sqlite defined chapter, which is going to have this thing. Now, for now they're independent entities, so let's just say book.hasMany chapter. Right. So what are we supposed to implement? Well, the idea here, right, is that in certain situations in our APIs, we're going to want to represent this parent-child relationship, right? We don't want to be able to access a chapter unless we go through the book. In order to avoid orphan chapters or to implement permission mechanisms and so forth. But we want this to be reflected, and it makes things a bit more clear. So let's consider the the sort of requests we're trying to address. So we're going to have app.get books bid chapters chapter ID. This is going to be a sync of request and response. Right, so this is going to give me a particular chapter of a particular book. Uh, Now, we might want to have all the chapters of a particular book. Right, this is going to be get books bid slash chapters. Now, this is also going to be the ideal place to add the chapter because we can't add an orphan chapter. We're going to post to books bid chapters. Now, the second, this third line is actually a prototype for put and delete, right? Because I want to go for book, but I need to have the chapter itself, right? So I want to have put and delete. Right, so this is what I'm basically trying to implement. So let's start from the top. The first thing I said we're going to sync the database, etc. But the first thing we want to see is actually not in these new endpoints. Is going to be when we got a particular book. Now let's say we want to. Now the book has a child entity which is chapter. Let's say we want to get a book and its chapters. Is this going to be done automatically? Well, the answer is no, because it wouldn't make sense. There's a difference to be made here between what is called lazy loading and what is called eager loading. So lazy loading means that whenever I load the parent, I'm not going to load its children. Eager loading means that whenever I load the parent, I am going to load its children. And the only reasonable default is lazy loading. Because let's assume that we have an application which does some student management, right? And it has the faculties in the university and so forth. So let's say we request a particular faculty. If by default we'd load its children, we'd actually load the faculty and we'd be forced to load its specializations. And then we're going to, if we load those, we're going to be forced to load its series, their series, and then their groups, and then the students. So we have the basically the whole database delivered over the internet. So that doesn't make sense. So the default is lazy loading. However, I obviously might need to also load the children. This actually connects to the join discussion because what I'm going to do in this situation, what's going to happen is a join. So if I look at book here, let's say whenever I get a particular book, I'm also going to get its chapters. The way to do this is I'm going to have a second parameter, right, which is going to have the same possibility, the same possible keys as the first parameter of find all. So here I'm going to do include chapter. If I have multiple things I want to include, I'm going to send them in an array. If I have if I want to include children of children, I'm going to use an object here, and I'm going to say model chapter and a bunch of other things, including an include. Right. So that we can actually see at this point. Let's do a couple of things. Let's sync the database. Let's run our server. We're going to do many to many as well, but probably not today. Right? We forgot to install our dependencies. So let's run our server, and we're gonna leave it running for the rest of this. So let's sync everything up. No? Okay, finally. Right, now let's add a book. Since we've deleted everything, we know it's going to have ID 1. And if we request it, we're going to see what did we modify here. Did we modify this? Include chapter. Right. Okay, so chapters were not created actually. Wait one sec. Oh, we've modified simple API instead of modifying the other one. Let me just fix this for a bit. So let's call this one to many. Right. Node mon server.js. Let's sync it again. Add a book and get a book, a particular book. Hmm? What am I doing? Let's see. One sec. This is so isn't this what I've? Yes, it is. Right. So why was the chapter not created? Oh yeah, no. So chapters. One sec. Right. Let's check if everything is created. Right. Now it's created. There was some stale reference. I kept on running the old one. Right. So we've created our book, and now if we get our book, we're going to see that we have a new key called chapters. Obviously, we've not added any chapters, so it's an empty array. But, as we're going to see later, if I do add some chapters, it's going to have something in it. So now let's return to these. In order to test something significantly, we should get these two endpoints covered, right? So it's getting all the chapters in a book and adding a chapter to a book. Right, so in order to add chapters to a book, or to get chapters from a book, we're going to need to have the book, right? So we can start from this particular endpoint. So this one, we're going to ignore the include, but we need to have the book, otherwise it doesn't make sense. Now, additionally, I was saying that these things, so the if I get the book, this thing is actually a complex object. It's not just the data from the database. So let's see what we can do with that. So it's a complex object. So if it exists, we can say const chapters is book. Oh wait, book dot get chapters. Now this is a somewhat strange method, right? But it's actually being created dynamically at runtime by Sqlite. So we can now give the chapters back. What about adding a book? Well, the logic is going to be similar. We're going to start from this. So we need the book because otherwise it's not going to work out. Then we need to create a chapter. So we're going to say chapter is, well, we have to get the chapter from the user, so it's going to be request.body. But there's something missing there, right? And what's missing is chapter dot book ID is going to be book.id. And then we're going to say await chapter dot create of chapter. And then we're just going to respond that it's been done. We're just going to say created. I'm just going to take it from here, and let's just put created here. So 201 created. So we can actually test all these things out. So let's go here. We're not going to recreate anything. So it's this one is empty. Get book 1. Let's see what happens if we get books 1 chapters. Well, what we expect to have happen is to have an empty array, and we do. Now, what if we add the chapter? Well, we're going to have to post to this address. Again, we're sending the entity, so content type. And we have to send the chapter to the server. Uh, this is why we cheated and we used the same structure because we wanted to write a little less. So we're gonna say some chapter title and some chapter content, and we can post this. It's been created. Now, if we get all the chapters of the book, we're gonna see that the array is no longer empty. And if we look at the include variant, right, so just get books 1 but including chapters, we're gonna see that it's actually part of the structure. So I get this little tree of entities. Right, so this covers this part. What about the remaining ones? So I need a particular chapter of a particular book first, and then I need to be able to edit it and delete it. So we can start from getting a particular book. Again, it's going to be similar to this one. So let's just take this one. So we get the book. If we can't find the book, we don't want to continue. Right? That's it. Now this is an interesting line because if we want to get the chapter of a particular book, let's just say chapter. The question becomes, can we use a condition in get chapters? And the answer is yes. Unfortunately, we don't have the equivalent of get chapters for one thing. We just have it as a select many, let's say. And we can do this. We can say where ID is, sorry, it's where, oh, well, one sec. It's where ID is request params sid. We can do this. Unfortunately, we get an array, so we have to extract the possible chapter from the array. So this is actually chapters, yeah. So the chapter is chapters dot shift. And now we have two possibilities. The chapter might exist or it might not exist. If it exists, we're going to send it to the client. And if it doesn't, we're going to say not found. Let's be a bit more specific this time so we just know what, so we can see what was not found. So this is chapter not found, and this is book not found. And we can actually test this independently, so we can get here and perform a request, which is going to get us the chapter 1 of the first book, the first chapter of the first book. And I got it. Now, as in our previous adventures with the book, we can actually use this as a prototype for put and delete because neither put nor delete makes sense if the entity they replied to doesn't exist. So let's do this. Now, if the chapter exists this time, what we want to do is await chapter.update of request.body. Now, obviously, this may or may not need validations depending on what our application does. Because can we move a chapter from a book to another book? I don't know. It depends on how we specify the application. But for this example, we're just going to update it. And then we're going to say accept it. Let's just find and accept it here. Right, so accept it, accept it. And for delete, we are just going to destroy our chapter. Right, so that's basically it. Let's test it out. So if we take this address and do a put to it, yeah, so content type application JSON, and we need a chapter. Let's take the chapter. Let's create a chapter from here. There's something wrong with the header. Now it's application JSON. So we're gonna say modified chapter title, modified chapter content. No, no, that was not it. Right. Sorry, one sec. I did a misclick. Oh, this is slow. Right, so one sec. Let's wait a bit. Right, so we want to put something to chapters. Let's check if it remembered what we wanted to do. Yes. Right, so it said accepted. Now if we get the chapter, we can see that it's been modified. And if we delete this, we should get chapter not found when we run this again. And indeed we do. We don't have time to go through any other things today, so I'm going to stop the recording and take any questions you might have.